So now to start with the next command, we are going to see the GD&T and the symbols of GD&T. How to apply GD&T as well as editing the templates. So to start with GD&T, first I am going to refer one image here. Now you can see here, these are the GD&T symbols, these are the characteristics, and these are the features. So to start with, first you can see a straightness. One line has been given. It comes under the category of form. Type of control is form. So whatever the characteristics that are coming under form, such as straightness, flatness, circularity and cylindricity, they does not require any datum feature or a reference. Whereas the characteristics that are coming under profile, that is profile of line or profile of surface, they may require datums here. It is optional for them. And after profile, these three controls, that is orientation, location and runout, which are having characteristics such as perpendicularity, angularity, parallelism, symmetricity, position, concentricity, and runout type means circular runout and total runout. Each character requires datum references. So these are the symbols been given. Straightness symbol it is here, flatness, circularity and cylindricity. This arc is for profile of line. The semicircle is for profile of surface. These are the signs for orientation, perpendicularity, angularity and parallelism. And these are the types that are symmetric, positions and concentricity, which comes under location. And runout, you can see this one single arrow, that is circular runout, and the total runout. It is given here. Now we are going to refer one more image here. So first we are going to understand straightness. You can see here it is given that relative datum is not required. So what is straightness? So straightness is a tolerance that controls the form of a line somewhere on the surface or the feature. Axis straightness is a tolerance that controls how much curve is allowed in the part axis. There are two ways that straightness can be shown by GD&T, that is on the surface straightness as well as the axis straightness. So whenever the axis straightness is being shown, you can see here this modifier has been added, that is maximum material condition. So to understand more about maximum minimum material conditions and all the modifiers, you can join us at 4 dimensions infotech. Now here you can see one frame has been given showing a cylindrical part, and this surface straightness is measured by dial gauge indicator by moving the indicator from this end to the other end in a straight way. Here the axis is also been given. You can see this tolerance, this is dimensional tolerance. You can see the diameter plus minus 0.05. It is representing the dimensional tolerance, and this frame is representing the geometrical tolerance. So the main difference between geometrical tolerance and dimensional tolerance is that any tolerance that is controlling only one dimension, it is called as dimensional tolerance, and the tolerances which are applied for the complete geometry as well as dimensions, that is called as geometrical dimensioning and tolerance. In short, GD&T. After straightness, you can see here the image has been shown how the straightness has been calculated here. Next one is flatness. Here it is written that datum is not required here also. Now the flat tolerance refers to two parallel planes. You can see here these two parallel planes that define a zone where the entire reference surface must lie. So it is showing two reference planes or two imaginary planes under which the surface, even after having some waviness, is laid down. So here these two planes are representing the tolerance zone, and the distance between these two tolerance zone is 0.03. This symbol is representing the flatness, and here the arrow is showing the surface which required to be flattened. When you manufacture any part cannot be accurate or precise according to manufacturing. So to compensate the deviations, this GD&T tolerance has been applied here, showing that if the waviness occurs in the flatness, it should not exceed the tolerance zone given here. So these two parallel planes are presenting the tolerance zone. So now talking about the measurement of flatness. Flatness can be measured using the height gauge run across the surface of the part if only the reference surface is held parallel. So flatness can be measured using the height gauge. So sometimes it is asked how the flatnesses and other GD&T characters can be measured. So here it is given that it can be measured by using height gauge. Now you should have the knowledge of measuring instruments also to understand GD&T. Means what is the least count of height gauge and how the height can be calculated by using height gauges. Now the third symbol here, it is given as circularity. It is shown that it is relative to datum No, means datum is not required in this characteristics also. So the circularity symbol is used to describe how close is the object to be in a true circle, sometimes called as roundness. So now it is saying that a circular symbol is been used to represent this particular circularity or roundness. So you can see here on one cross section this roundness has been measured, and here this is the tolerance zone, the inner blue circle and the outer blue circle, and this curve is representing the actual surface which has been manufactured here. So one zone is been given here also, representing the roundness or cylindricity of any part. Next is cylindricity. Here also datum is not required. One part is been shown, circular part, showing the tolerance zone value or tolerance value of 0.03 with the symbol of cylindricity. Now cylindricity, there are two concentric cylinders shown here, that is this two blue circles, and the actual part is this red circle. So now the cylindricity is measured not only according to cross section but also the total surface of the cylindrical shape. So now cylindricity is referred to the part which needs to be round and straight along its axis. For example, such as a sliding shaft. Here it is shown the profile of line and the datum is optional here. But you can see in this frame the datums are also being shown. Datums are nothing but they represent the planes which are used to constrain the part. Or you can say the meaning of datum is nothing but references which are used to constrain the part. So here A and B datums have been given, and here this symbol is representing the profile of line, and this is the value of tolerance zone been given here. So now you can see here these two lines are representing the tolerance zone, that is 0.03, and the actual surface is lying between these two reference lines. If this line exceed above or below these two reference lines, then you can say the profile of line is not up to the mark as we require. So this is the datum A, that is this flat surface, and the side face, that is datum B. The next is given here as profile of surface. Relative datum is still optional. Here is the frame representing the two datums, tolerance zone or tolerance value. This semicircle is the symbol of profile of surface. So here you can see a three-dimensional tolerance zone existing of two parallel surfaces that follow the counter surface, this surface, across the entire length of the surface. So now this tolerance zone is referred following the entire surface here. In profile of line, it was only covering one cross section, but in profile of surface, it is covering the entire cross section. So these are the two parallel planes representing tolerance zone in which the surface must lie. When the parts are made of castings, that time the surface profile is very much used to control the amount of variations being made by the time of manufacturing. Usually CMM machine is used to measure the complete surface of the profile, and it is usually used for casting parts. Next one is angularity. Now here the datum is compulsory, you can see. Relative to datum, yes. Now in this character, two parallel planes of line which are oriented at the specified angle, you can say this angle here, and all the points of the reference surface must fall under this tolerance zone. So the points of this reference surface must lie under one tolerance zone which is around this surface, and the size of the tolerance zone is 0.03, you can see here. It is referred with this datum, that is datum A. Now the angle is being measured by this bottom flat surface, that's why it is shown as a datum here, and this surface has been measured. The angle is given and the tolerance zone is also given. So you can see the presentation here. So if the surface vary with the angle, it should vary within this tolerance zone only. You can see here these two parallel planes are representing the tolerance zone for that particular surface. Angularity is measured by using or constraining the part, usually with a sine bar, tilted to the reference angle so that the reference surface is now parallel to the granite slab. You can see the arrangement here. Next here it is given parallelism relative to datum. Yes, parallelism is fairly common symbol that describes the parallel orientation to one reference feature to the datum surface. So now the bottom surface is the reference surface, and this box upper face, that is this red face, should be parallel to the reference surface. If the deviation occurs, it should occur within this tolerance zone that has been given here. Now this parallelism is quite simple to measure, like flatness. A gauge is run across the surface or a feature. Perpendicularity. Now this is also related to datum. Now perpendicularity, when reference datum or reference surface has been given, that is referred as a datum. So the bottom surface here, that is horizontal, is a datum surface, and this side face, that is vertical face, it should come perpendicular to this datum reference. So that's why the symbol is being shown here. Now the tolerance zone is also being shown. You can see here, this figure is showing the deviation of the surface with the reference. But this deviation, if it is coming under this tolerance zone, then the surface can be considered as perpendicular to the reference surface. So these are the two parallel planes being shown here in which the surface must lie. If the deviation occurs, that must lie within this zone only. Next is position. So now you can see here, this hole has been placed on this plate, and now here one reference is given, the bottom surface as a datum A and this side right side face as a datum B. So here these two values are also referred by the two datums only. That's why these two datums are being represented in this frame, showing the tolerance zone as well as the diameter symbol. It's been shown only when in the tolerance zone it is going to be circular. In other cases, this tolerance zone was coming in between these two parallel lines, but in this case, here the zone is going to be circular, and within that circular zone, the center point of this hole must lie. So that circular zone diameter is showing here as 0.03 with reference to A and B. This A and B are referred only because these values are being referred from that particular surfaces. So this is the symbol here. And it is also being shown that diameter is given with the tolerance value. So this is the dimensional tolerance and this is the geometrical tolerance. Next we are going to see here is concentricity. It is also relative to datum. Now in this backside shaft surface is referred as datum axis, and the front side shaft axis, it should come relative with this datum. So now if the front side shaft axis does not come collinear with the backside shaft axis, then you can say that concentricity has been disturbed. But if the deviation comes under this tolerance zone, that it is shown here, you can see this is the circular tolerance zone, and now here also the value will be represented by diameter symbol showing the tolerance zone, as this tolerance zone is circular. Next is symmetricity here. It is also related to datum. Now one imaginary plane coming across this cut profile in this center is being shown here. So now this two surface, that is the above surface here and the below surface, this surface, both should have equal distances from this center plane so as to apply GD&T. Means these two surfaces must be symmetric with this particular center plane, and if it deviates means symmetricity has been applied, and if it deviates then it should lie within the tolerance zone for the tolerance. Next is runout. Datum is required. Runout is combination of concentricity and circularity. It is essentially how much wobble occurs in the part or a feature when the reference part is being rotated. So here you can see these two shafts are being kept, and this backside shaft has been rotated along with the front shaft is also been rotated. But if the deviations come while rotation by the backside surface of the shaft, then it is called as circular runout. Means the runout is occurring at the cross section of the shaft. That's why this is referred as datum A, and these blue circles are showing the references that are tolerance zone. It is measured using dial gauge, you can see here. This is the gauge block on which the shaft has been rotated, and this dial gauge is counting the vowel that has been occurred in the first shaft with reference to the second shaft, the back shaft. Now the last one is total runout. Means it is the combination of concentricity and circularity. Total runout is how much one entire feature or surface vary with respect to the datum when the part is rotated 360 degrees around the datum axis. So now this part is rotated along the datum axis, and this complete feature, how much it varies from this datum axis, that has been measured, showing the wobble moment. And if the wobble moment occurs exceeding this tolerance zone, then we can say that this front shaft is coming with total runout with reference to the back shaft. Now you can see it is measured along the surface with this straightness as well as along the cross sections at regular intervals. So more than one or two readings are being taken here so as to measure the total runout with reference to this straightness also. So these were the symbols. Now we are going to see in SolidWorks how these are being applied. So first we will apply the datum features here. I'll take this as a datum A, the bottom face, this side face as datum B, and this space as datum C. So now datums are being applied. So now we are going to apply geometric tolerances here. So to start with, this option has been given geometric tolerance. You just need to select this surface where you want to apply the geometrical tolerance. So I will select this surface here and I need to show perpendicularity with reference to datum A. So here you need to add the value and then place this box here. It will show the geometrical symbols which are needed to be applied. So I'll apply here perpendicularity and now this value is coming for the tolerance zone. So I'll take this as 0.2. I'll also add datum here. I'll say datum A only and say done. So now this option is showing to complete the command. These are the modifiers which may be required in between. You can apply the modifiers also here. I'll say done now. Now this frame is showing that this particular plate is perpendicular to the surface being shown as a datum. Next, we are going to apply positional tolerance. For that, we are going to refer this hole here. So to start with, I'll select the geometrical tolerance, select the hole, place the box of the geometrical frame, apply the type of tolerance symbol as well as value. I'll say it's 0.02. And now this positional tolerance is usually referred by the circular tolerance zone. That's why I'm going to add diameter symbol also here. So this symbol has been added, you can see here. After that, I'm going to refer the datum. So for datum, you can see here. If I want to place this hole's position, then I will refer the position by giving dimension from this vertical side, this side, taking the reference of datum C here. And next I'm going to show the dimension by the side of this space representing the horizontal dimension. So for vertical dimension, I'm going to refer datum C. And for a horizontal dimension, I'm going to refer datum B. So for that only, we need to add here two datums. So we will go here and say first datum as C and the other one as B. So to add other one, I need to click on this add new symbol and here you can say the other datum as B. It should come in capital always, and then if you need it, you can add modifiers also here. I'll say done. So in this way you can apply the GD&T symbols. Now I want to show this inner circle is concentric with the outer circle. So I'm going to take this reference of the outer circle. That's why I need to apply one datum here. So I'll select the datum feature and I'll say this as a datum D. To add GD&T, I'll select this option, place the frame, go for the symbol. I'll say concentricity, apply the value for the tolerance. Now the tolerance zone for concentricity is always circular. That's why I'm going to add the diameter symbol also here. Now add the datum symbol. So I'll say it as a datum D. It is because we are going to refer this circle as a reference datum. That's why we are adding D here as it was named D. So say done after completing. So in this way we can add GD&T symbols in SolidWorks.